Now I want to tell you one new concept, next chapter, that is permutations and combinations. To start the chapter permutations and combination, I would like to salute the mathematician who started and originated this concept, Jacob Bernoulli. This thought of thinking that how we can arrange and select the numbers. So this kind of concept is belonging to our topic permutation and combinations. But before we start, there is one very important aspect to understand, that is what is the meaning of factorial. If the term factorial I want to define, I want to explain you, there is a very simple logic about the factorial. Factorial is nothing, is the product of n consecutive natural numbers and starts with 1. Suppose I say 1 into 2 into 3 into 4. 1 into 2 into 3 into 4, it is given by factorial 4. One of the symbol is factorial 4. So the product of first n natural numbers is given by the factorial. That is, this is the expanded form of multiplication of first 4 natural numbers, and this is its compact form, that is symbolical representation. Factorial 4 means product of first 4 natural numbers, or we can say it can be written as 4 factorial like this. So question is to understand the concept of permutation and combination given by Jacob Bernoulli, we have to understand what we call the product of first n natural numbers. Suppose if I say what is the answer of factorial 5. So obviously I have to start with 5, 4, 3, 2 and the least natural number is 1. So what is the answer of factorial 5? It is coming out to be 5 4 ja 20, 23 ja 60, 62 ja 120. So answer is coming 120. It's very simple that whatever factorial is written, what we need to do, we just need to multiply first n consecutive natural numbers. You just can understand what is the answer of factorial 4. Answer of factorial 4 is 4 into 3 into 2 into 1. So answer is coming out to be 4 3 ja 12, 2 ja 24. So again a logic very simple, but in case we should not go for any mistake that return factorial 5 minus factorial 4. It's not the ordinary subtraction that one is saying factorial is common, 5 minus 4 is 1. It's not. It's what? First we will go to calculate the value of factorial 5. What is this? 120. Then what? 24. So it means that it is coming out to be 96. So it means whenever we are solving the factorials, first we need to find the values of factorials. Another symbol, mostly it is written factorial like this or this. They have the same meaning, same logic, same answer. Similarly, if somebody says what is the answer of factorial 5 into factorial 4? Obviously not factorial 20. First of all, we will write 120, the value of factorial 5. Then we will write 24, that is the value of factorial 4. Their product, that is 0. Then 12 4 ja 48. Then 4, 12 2 ja 24. Then 24 plus 4, 28. So this 2880 is the answer of factorial 5 into factorial 4. We should never go for first multiplication then factorial. Whenever we are solving the problems related to factorial only, we just need to simplify first factorials, then mathematical operations. Similarly, if you want to find the value of factorial 5 plus factorial 4, this answer definitely not equal to factorial 9. Its answer is 120. Factorial 4's answer is 24. This is coming out to be 144. Similarly, if you want to divide factorial 5 upon factorial 4, it is what? The answer is 120 upon 24, answer is 5. So my first purpose before to give you a very much detail about permutation and combination, there is one concept related in the chapter is factorial and how to operate, which I told you factorial is the product of first n natural numbers. Whatever factorial you want to find, suppose you want to find factorial 10, it is the product of the natural numbers from 1 to 10. Factorial 9 is the product of first 1 to 9, and similarly and some other operations like subtraction, multiplication, addition and division. When we are doing mathematical operations are later, but this factorial needs to be operated previously. So this concept was given by Jacob Bernoulli, and it is somehow related to solve the problems with the factorial, and factorial is the product of first n natural numbers. Now I want to tell you how to operate, how to apply when we are solving the problems related to factorial. In order to start this, there is a method like I am giving you a problem. If 1 upon factorial 9 plus 1 upon factorial 10 is equals to x upon factorial 11, then find the value of x. Find what is the answer of x. In order to solve this problem, first we must convert all the numbers, whatever written in the factorial in the denominator, into its least factorial. That is, here is this factorial 11, it is factorial 10, and this is factorial 9. So when we will solve, first the least factorial is factorial 9. We will not disturb it. Plus 1 upon factorial 10. Meaning of factorial 10 means product of, that is product of first 10 natural numbers, which can also be written as 10 into factorial 9. 10 into factorial 9, meaning by that this factorial 9 is the product of first 9 natural numbers and 10 is here. So ultimately still it is the product of first 10 natural numbers. So I have bring this factorial 10 in the shape of factorial 9. Similarly, in the right hand side, factorial 11 can be written as 11 into 10 factorial, but 10 factorial still needs to bring out up to the level of factorial 9. So it can be written as 11 into 10 into factorial 9. Factorial 9 is the product of first 9 natural numbers. Then when this multiplied to 10, this become factorial 10. Then when this multiplied to 11, this become factorial 11. So still this value is factorial 11. This is factorial 10. This is factorial 9. After doing it, it helps you in taking the LCM. LCM is, that is both sides. In order to dilute it, I am taking 11 into 10 into factorial of 9. So what result is coming? This become 110 because factorial 9 and factorial 9 get cancelled. What left? 11 into 10, that is 110. Plus when this get cancelled, what left? 11. And is equals to this entire is cancelled, what left? X. So as a common in whole, we can leave it. So what is the answer? 110 plus 11. So answer of x is coming 121. So basically we can solve the problems related to factorial, even to find the value of x, value of any other variable, some addition, subtraction, multiplication, etc. But key point to understand that whenever many factorials are written and we want to take the LCM, we will bring every factorial up to the level of the least number factorial involved in that problem. As we did in this example, all factorials have been brought to the level of factorial 9. Now I want to explain you one more example where I will explain you how to find the value of unknown variable. It's again a very simple, that if this is the given, that if factorial k plus 2 is equals to 30 into factorial k, then what we need to find? Find the value of k, or if someone extends its level of difficulty, find the value of k plus 1 factorial, k plus 2 factorial, factorial k square, whatever it is. So first I am going for the basic. If factorial k plus 2 is equals to 30 into factorial k, if I ask you to expand factorial k plus 2, what we will do? It will be k plus 2 is the first number, then 1 less to it, k plus 1, and 1 less to it is k, which I want to write factorial k. And the right hand side is 30 into factorial k. So what is coming? Factorial k plus 2 is k plus 2 into k plus 1 into factorial k. As you know, if factorial 10 is written, I can write it as either 10 into factorial 9, or we can write 10 into 9 into factorial 8, or we can say 10 into 9 into 8 into factorial 7, and so on. So it's a great, it is k plus 2, k plus 1, and 1 less to it is factorial k, which is equals to 30 into factorial k. So factorial k and factorial k get cancelled, as k cannot be equal to 0. So we are getting k plus 2 into k plus 1 is equals to 30. K plus 2 and k plus 1, these are the two consecutive numbers. So I can say that k plus 2 into k plus 1 is equals to 6 into 5. Or you can apply after multiplication of the left hand side and transferring 30 from right to left, there will be a position of obtaining the quadratic equations solution. But here I am taking as 30 is also expandable as the product of two consecutive numbers. So bigger number is 6, in the left side the bigger one is k plus 2. So what I can say, the answer of k plus 2 is 6 and answer of k plus 1 is 5. What is coming out to be? K is equals to 4 and this become k is equals to 4. So if some problems with some variable are given, then approach is the same, that convert, write all the factorial results either in specific or in general to a particular level where the least factorial is given, then take some common, proceed, go for factorization, comparison, and find the value of that variable which is required. Now I want to give you one more example which is again related to the problems of the factorial general expansion with some trick. Prove that factorial 11 is divisible by 2 is to power 15. In order to prove it, first of all, I will write the expanded notation of factorial 11, which is 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 into 10 into 11. That is usual. Whatever is the product factorial, it is the product of that much consecutive natural numbers. This become, if I separate even and odd, so 1 into 3 into 5 into 7 into 9 into 11. These are the odd numbers, and now the even numbers are 2 into 4 into 6 into 8 into 10. 2, 4, 6, 8, 10. If I say this product is symbolically given by the alphabet A, I have assumed that product of these odd numbers is A. Then what left? Product of these even numbers. 2 I can write 1 into 2. Then 4 can be written as 2 into 2. 6 can be written as 2 into 3, 8 can be written as 2 into 4 and 10 can be written as 2 into 5 because each number was even, so it was the product of 2 in each case. I am finding this is A into. This is 2 once, twice, thrice, 4, 5. 2 is coming 5 times. I can say it is 2 is to power 5. And remaining numbers, after taking 2, what will left from first bracket? 1. What will left from second bracket? 2. I am taking only 2 out of these 2 2's with the sequence of the pattern. Then it is 3, then 4, then 5. So it is very much clear that this product of factorial of 11 is having 2 is to power 5 as a factor. So we can say it is divisible by what? It is divisible by 2 is to power 5. Permutation and combinations, these two depends upon the two principles. One is the principle of addition and other is the fundamental principle of multiplication. If I will explain you that most interesting example, that if a teacher is teaching in a class having 30 boys and 20 girls in the class, teacher would like to select, there are how many boys in the class? 11th, boys are 30 and the number of girls is suppose 20. There is a class of 50 students. Teacher want to select one boy or one girl. That is, teacher, he or she is interested to make one monitor. That is, if one monitor, either a boy or a girl. So remember, whenever the word either or exists in the problem, then we apply the fundamental principle of addition. So in how many ways a teacher can opt or choose a class monitor out of 30 boys and 20 girls. So either a boy will be monitor or a girl will be monitor. So we have how many choices? 30 boys and 20 girls. So it means that there are 50 choices. So remember, whenever we will solve the problems related to the permutation and combination, we will read the problem very carefully and we will try to diagnose that which principle is applicable. Either the fundamental principle of addition or the fundamental principle of multiplication. Suppose a fundamental principle of addition, it can be diagnosed, recognized that if in the problem the word comes either or, then we can say a teacher can select a monitor in how many ways? 50 ways. If teacher want to select two monitors, one boy and one girl, if in the problem the word and comes, one boy and one girl, it means that it will be 30 into 20. That is, the fundamental principle of multiplication will apply in the question if the question says and. That is how two monitors, very simple to explain. Suppose roll number 1 is a boy or Amit is a boy, then with Amit, how many girls can be made monitor? 20, any of the girl. Similarly, with roll number 2 or with the second boy, any of the girl can be monitor. So there are 30 choices from the boys, and with each boy, how many girls are possible to make monitor? 20. So 30 plus 30 plus 30 plus 30, how many times? 20 times. Repeated addition, 30 into 20. So what become? 600. So it's very simple that we have two principles, two fundamental principles to solve the problems of permutation and combination. One is the principle of addition and second is the principle of multiplication. we should take care whenever in the problem either or word come, we should try to learn for the principle of addition, or we can think that how and why the principle 1 or 2 is applicable. And if in the question word and comes, that is out of 30 boys and 20 girls, a teacher is interested to make 2 monitors, one from boy and one from girls. 30 into 20, he is having 600 options. But one monitor either from a girl or from a boys, or that is the answer. 30 plus 20, that is 50. So read the problem carefully, try to diagnose, try to understand that which principle, which fundamental principle is applicable, and then apply and solve the problems. I am going to explain you few more problems related or based on these 2 principles. I am taking one example where we will diagnose that which principle, addition or multiplication, will be applicable. So the most important funda to solve the problem is read the problem very carefully twice or thrice. How many words with or without meaning can be made out from the word Krishna? So the question is, if these words, these letters are reshuffled as many times you want, in what way you want, then how many words are possible? This is the question. So there are 1, 2, 3, 4, 5, 6, 7. There are 7 distinct letters used in the writing Krishna. So first of all, we need how many places? 7 places. 1, 2, 3, 4, 5, 6, 7. So if I say this is the position number 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. In how many ways first position can be filled? Out of 7, firstly I have choice to opt any of the letter, that is in 7 ways. Then in the second place 6 ways. Then on next place, because what letter I have used on the first place I have 7 choices, any of K, R, I, S, H, N or A. Out of these 7, any one of the letter can be used. Then whatever is used, I cannot repeat because I have to use all the letters together. Then on the second position, one letter which is used is less. So 6, then 5, then 4, then 3, then 2, then 1. So the question, the product of this can be written as factorial 7. So this is a basic question where none of the principle is going to apply. A very ordinary way we are thinking that in how many ways or what is the total number of arrangements is possible. You must know arrangement stands for permutations and selection stands for the combinations. So this answer of arranging and finding the total number of words can be made from the letters of the word in the Krishna is factorial 7. I am taking another example that in how many ways we can select one ball out of 3 red, 4 black or 5 green. That is, if there is a bag having 3 red balls, 4 black balls and 5 green balls. That is, one compartment having 3 red balls, another compartment of the bag having 4 black balls, and the last compartment having how many balls? That is the 5 green balls we have. How many balls we would like to select? We would like to select only one ball. That is, either the ball will be of red color or will be of black color or it will be of the green color. So the problem is giving us to give a thought that which principle is applicable. We are selecting one ball. In one box, 3 red balls. In another box, 4 black balls. In another box, 5 green balls. So, if we would like to select ball of red color, what is meaning by this? That we are having 3 choices. Similarly, if I want to opt a ball of black color, I have 4 options. And if I want to select a ball of green colors, I have 5 options. So the question is, either we will take a red ball, or we will take a black ball, or we will take a green ball. So here, how many ways? Total number of ways of selecting the ball is either a red, or a black, or a green. So this will be 5 plus 4, 9 plus 3, 12 ways. So it is very simple to read and then to identify that which principle is applicable. Suppose if I extend this question, that if you want to select 3 balls, one of red color, that is what? 3, and one of 4 out of 4, that is black, that means into 4, and one of green, that is into 5. So whenever we are saying that and word is coming, that we are multiplying the principle of multiplication. If or word, either or is coming, we are multiplying the principle of addition. So there is no issue that which principle is applied. Read, think and identify. So this become, if one ball either red or black or green is required, it is 3 plus 4 plus 5, that is 12 ways. And if there is a possibility to take 3 balls, one of each color, that's mean one red and one black and one green, that is sign of multiplication. So this is coming what? 5, 4 is 20, 3 is 60. So this is principle of multiplication, and this is the principle of addition as per requirement of the question. This part I have extended to differentiate the two principles. Now I am taking one more example where we will identify that which principle is required to use. Given 7 flags of the different colors, we have 7 flags, each is of different color. How many different signals can be made out if 2 flags of the different color are used, and if 3 colors of the three different flags are used? Question is that we have 7 flags, 1, second type 2, then 3, then 4, then 5, then 6 and then 7. These 7 flags are distinguishable, maybe of different color or whatever. It is written different color, it means that 7 flags of the different color. If a signal is required to generate, and in making in that signal, if 2 flags are required. So in the first case, if I say 2 flags are required, means on the upper part of the flag of the signal, what choices we have? We can use any of the 7 flag. But whatever flag is used, it means that to make a signal, same we do not have and we cannot use. For the second one, we have 6 choices. So to make a signal, when we are using the 2 flags of different color, we are obtaining the answer 7 into 6 is equals to 42. First thing. The second, in continuation of it, that if I use 3 flags, so it is first flag, it is the second, it is the third. So how many choices I have here? 7. How many I have here? 6. How many I have here? 5. That means 7 6 is 42, 5 is 210. So we can make 210 signals if we use 3 flags at a time, and we can make 42 signals if we are using how many? That two flags, two different flags at a time. So this is very simple, not a difficult, just to identify and apply the method of principle as per the requirement of the question. Now I would like to explain you that what is the total number of arrangements possible if r objects are taken at a time out of n number of objects where r is less than or equal to n. So the formula of the permutation, that is NPR. It means that if r items, r objects are taken at a time, if available number of items is n. So obviously this n should be greater than or equal to r. So the result is given by factorial n upon factorial n minus r. So it is simple that NPR, it means that number of permutations or number of arrangements if r objects needed to taken. For example, if you have 7 books of different writers, of different authors of mathematics, and you want to opt 4 books for the preparation of exam. So that will be out of the 7 books of different authors and different publications, you want to opt 3. So it means that this is a combination. But if you want to opt these books in different ways, that is first this book, second this book, so number of arrangements, if 3 objects are to be taken out of 7, the number of arrangements is given by factorial 7 upon factorial 7 minus 3 as per this specification of the result, which become factorial 7 upon factorial 4 equal to 7 into 6 into 5 into 4 factorial upon 4 factorial, get cancelled. This becomes 6 5 ja 30, 7 ja 210. So there are 210 ways of arranging 3 objects at a time out of a group of 7. So permutation is the linear arrangement. Arrangement is permutation or permutation is the arrangement. If there are 7 objects or 7 students would like to stand in a line, it means that it is a question of linear permutation. So answer is factorial 7. But the arrangement of few things, lesser things if available is more, that is the NPR, factorial n upon factorial n minus r. R is the number of objects to be taken out of n. So this is the formula applicable when we will solve the problems related to permutation. Now I want to explain you the concept that why factorial 0. My purpose is to explain you that why we say factorial 0 is 1. And you also know that factorial 1 is also 1. But if you equate, you will get to know 0 is equals to 1, which is a wrong. So it means that I am going to emphasize you that why this factorial 0 is considered to be 1. Reason is, as I told you that NPR is given by factorial n upon factorial n minus r. In case if I say there are n eatable items available, suppose you have rice, you have vegetable and you have some sweets, and you want to have all 3, but it depends upon the person that in which order one want to have. First sweet, then vegetable, then the third. Similarly, someone can take first rice, then this, then that. So if order matters in answering a question, it means problem is related to permutations. If order is not mattering, problem is of the combination. So here if you have n objects and out of available n objects you want to opt all and you want to opt in the different orders, then total number of arrangements is factorial n. So ultimately out of n available objects you want to take all, but order is mattering, then it means that answer is factorial n. As you want to arrange the 10 items in the row, you want to take 10 out of 10, answer is factorial 10. You want to take 6 out of 6, answer is factorial 6. Similarly, you want to arrange 40 students in a line, so there are arrangements that how many? Factorial 40. The line can be start with any one of the student, which is also being explained to you previously. So if n objects are available, we want to arrange, then we have factorial n ways and npn. npn means out of n available objects, we want to take all, but in the different order is a separate combination, selection. So this is factorial n. So in place of this formula of npr, if I ask you to replace r by n, what is going to be? npn is equals to factorial n upon factorial n minus n. Because in this result, I am asking you to replace this r by n, then the shape of the formula will be npr goes to npn, RHS factorial n upon factorial n minus r means factorial n minus n. But npn, I have told you, it is factorial n. npn is equal to factorial n and is equals to factorial n upon factorial 0. N minus n is taken as factorial 0. So ultimately what we are opting by the multiplying cross and getting the factorial 0 as factorial n upon factorial n, which is equals to 1, which proves our result that factorial 0 is equals to 1. This was the task to explain you that why factorial 0 is 1. Reason is so simple. We have to know that if n objects are need to be taken out of n, then npn is considered as factorial n, and then applying the formula of npr like this and this result, replace r by n, we will get factorial 0 is 1. Now I want to explain you one application of the formula npr. Question is, if np4 equals to 12 times of np2, then what is the value of n? We know that the formula of npr is what? npr means factorial n upon factorial n minus r. So here in this problem, the left hand side np4 will be written as factorial n upon factorial n minus 4, because in this formula r is replaced by 4, which is equals to 12 into np2, meaning by factorial n upon factorial n minus 2. Problem, we can factorial n get cancelled. 1 upon factorial n minus 4 is equals to 12 upon what? We can write n minus 2 n minus 3 into factorial n minus 4. If there is a number, suppose 8, we can say 8 into 1 less 9 into 1 less factorial, whatever it is, 8, 7, 6 factorial. If it is 10, 10, 9, 8 factorial. We can write like this. With the help of this, we have cancelled even factorial this one also. So now we can cross multiply that n minus 2 into n minus 3 is equals to 12. As n is a natural number, so this is one of the natural number. This is again a consecutive lesser natural number, one less than this, is equals to 12. Which is what? N minus 2 into n minus 3 is equals to 4 into 3. Ultimately what we are getting, this is n minus 2, n minus 3, this is 4, this is 3. On comparing, we can say n minus 2 is equals to 4. So we can say n is equals to 6. Or what we can say, n minus 3 is 3, so n is equals to 6. Hence at n is equals to 6, this relation np4 is equals to 12 times of np2 will be correct. So this kind of applications are very much possible to ask you in the different problems. Now I am taking one more problem related to the formula of NPR. Prove that 1 into 1p1 plus 2 into 2p2 plus 3 into 3p3 plus dot 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 up to n into npn is equals to n plus 1p n plus 1 minus 1. In order to prove this result, I am taking the left hand side of the problem, this, where we are finding that if it is 1p1, it means that 1 is multiplied. If it is 2p2, 2 is multiplied, 3p3, 3 is multiplied, npn, n is multiplied. So we can write it as r into rpr, and the value of r starts from 1 and goes till which point? N. So the synchronized or the compact form of the LHS is this. Now we have to remember that this is r is equals to 1 to n. This small r can also be written as r plus 1 minus 1 into r p r. So ultimately you know n p n is factorial n. So r p r is factorial r. This r p r will now replaced by factorial r. So this become sigma r is equals to 1 to n r plus 1 minus 1 times of factorial r. When this factorial r multiplied with minus 1 will give us minus of r factorial. So this result is coming r is equals to 1 to n r plus 1 into factorial r minus 1 into factorial r. Now we are writing it r is equals to 1 to n. As we know it is factorial r and then a number multiplied one more than this. Like if factorial 10 is multiplied by 11 could be written as factorial 11. So here factorial r multiplied by r plus 1 gives us factorial r plus 1 minus factorial r. Now I will expand it. I will get, if I put r is equals to 1. On putting r is equals to 1, the first component will be factorial 2 minus factorial 1 is the second component of this sigma. If I put r is equals to 2, it will be factorial 3 minus factorial 2. If I put 3, I will get 3 plus 1, 4 factorial minus r means 3 factorial plus dot 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 plus. If I put finally n, it will be n plus 1 factorial. This is n plus 1 factorial minus n factorial. After simplification of all these results, factorial 2 will be cancelled by this, 3 by this, 4 by this, n by something. I will tell you, you will be left with only factorial n plus 1 minus factorial 1. Only these two values will left. But factorial n plus 1 is what? N plus 1 p1. As you know, NPN is factorial n, RPR is factorial R. So the value n plus 1 P n plus 1 is what? This can be written as factorial n plus 1 minus 1 as it is. So what is this? This is our required result which we would like to show. So this is one of the way of applying or putting the application of the result NPR. Now I am taking one example where some different arrangements will matter. The example is how many words with or without meaning can be made from the letters of the word Monday. Whatever is used in Monday, this is required to use. How many words with or without meaning can be made from the letters of the word Monday? Assuming that no letter repeat if first condition 4 letters are used at a time. I want to tell you, in writing the Monday, first part if I talk, in writing of Monday, how many we have used? Letters are 1, 2, 3, 4, 5, 6. So we have 6 choices, but we want to take 4 at a time. So 6P4, because they are asking the arrangements. How many words with or without meaning can be formed if 4 letters are taken out of the all letters used in writing of Monday? 6P4, which become factorial 6 upon factorial 6 minus 4. This is equals to factorial 6 upon factorial 2. Factorial 6 upon factorial 2 will be 6 into 5 into 4 into 3 into 2 factorial upon 2 factorial. This get cancelled. This become 6 5 is 30. 30 into 12, that is 360, the first part. The second part is all letters are used at a time. So NPN all means 6P6, which become factorial 6 upon factorial 6 minus 6, which is equals to factorial 6, and you know factorial 6 means 6 into 5 into 4 into 3 into 2 into 1. This answer 6 5 is 30, and next product is 4 3 is 12, 12 2 is 24, that is 720. And you must even remember few of at least 5 6 values of the factorial. Then the third part, all letters are used, but condition that first is a vowel. In writing of Monday, we have 2 vowels. So the first letter can be started in 2 ways. Then we have 6, but out of these 6, one is used in fixing the first position of word required to form. So how many positions are left? 5. So 2 into factorial 5, this become 2 into factorial 5 means 5 4 is 20, 23 is 60, then 62 is 120. So ultimately it is 120 into 2. Answer is 240. So we must remember that permutation can be linear, permutation can be taken all at a time, permutation may used with some condition that this much number of letters are taken, this much number of items are taken, we should start with this, we should end with this. So some sort of problems are possible in permutation. They will deal with some permutations of the condition. There are some problems where we will use the permutation, but the specific type of problems dealt with the finding of the rank. I am taking an example of that. The letters of the word random, I am talking about random. Whatever total number of arrangements are possible have been made. The letters of the word random are written in all possible order. That is, taking all letters at a time, and we have arranged that as many are possible to write the words which can be formed by taking the letters of the word random, and then arranged in the dictionary. After writing all these, we have arranged like in dictionary in their order of the alphabets. Find the rank of word random. Then we need to find what is the position or at which number this word random will come among all those which have been made. So my first question goes that using in writing of the random, what letters have been used? R, A, N, D, O, and one of the letter is O. So if we want to write all possible, then total number of letters 1, 2, 3, 4, 5, 6. That is factorial 6. 1, 2, 3, 4, 5, 6 factorial 6. That is what? 720 words are possible by making the use of this random. First thing. But if I tell you to arrange in the dictionary, first of all, letters which will start with A come first. So I am writing the order of the letters used in writing the random as per the dictionary condition. This is first is the A, then it is D, then M, N, O, and finally it is R. So as per the dictionary, the order is A, D, M, N, O, R. First I will fix as A. I am looking for all those words which will start with A. So to start with A is being fixed. If A is being fixed, how many letters are left? 1, 2, 3, 4, 5. So this becomes factorial 5, that is equals to 120. Then we begin with D, then factorial 5, again 120. If we come for M, factorial 5, then 120. Then begin with N, factorial 5, then 120. Then begin with O, factorial 5, 120. So number of words which can start with A is factorial 5 because A is fixed, remaining can change their position. So linear permutation for 1, 2, 3, 4, 5 letters is factorial 5, that is 120. Similarly for D, M, N and O. Now we are coming to start with what? D. This is told, then M. Finally we are coming for the R. But we are finding that we want to write what? We want to write random, R-A-N-D-O-M. So R, if I am writing, this R is cancelled because R is the first letter required in writing the random. So then we will go to check that this R is over. We will come after cutting on the top. Then we will take the second letter as A. In writing the random, second is A. Then we will write, after cancelling this, next is D, R-A-D. But third we are writing here D and third is here N. So this can be fixed, and after fixing this, we left with 1, 2, 3. So that is factorial 3, answer is coming 6. Now R-A, after D we will go to M. And if M is used, D is made free because we want to write random. If M is used, D is free, then 1, 2, 3. Again we have 3 choices, factorial 3, that is what? 6. Now R, A, after M we are going to write N. If it is N, then what left? 1, 2, 3. But we will take care that N is on the third position here and N is on the third position in the random. So cancelled from both places. Now we left with what? D, because we have to come at top. After cutting we will not go down, we will come at the first. Then we will write D. But D is again matching. So D is cancelled. After cancelling the D, we will go on the letter left is M. So this M, but here it is O. Here it is O. So if it is O and this is M not matching, so O, M is fixed, left is O, this is factorial 1. So answer is coming 1. Now R, A and D. After M we will go to O. O is used here and cancelled, only left is what? M. This become random. Now this is factorial 0. Then answer is what? 1, as I explained you. So total is coming 614. Hence we can say 614 is the rank of random out of 720 arrangements possible for this word. Now one more problem related to the same permutations, that how many words can be formed with the letters of the word university, that vowels remaining together. This is again a question of the conditional permutation. First I want to tell you UNIVERSITY. These are the letters used in writing the word university. So if I tell you that condition is all vowels remain together. First I want to tell you it is U once, then N, then I, then V, then E, then R, then S. Then again I, then T and Y. I want to tell you two I's are of same type. So it means that here even we will apply the repeated permutation. What is this repeated permutation? I want to tell you. Suppose I want to arrange A into A into A into B into B. So how many letters are used? 1, 2, 3, 4, 5. If these all are distinct, answer is 5 factorial. But if all these are not distinct as it is, so 3 are repeating, so divide by factorial 3. 2 are repeating, divide by factorial 2. So in case of repeated permutation, what we do, whatever letters or digits are repeating, we have to divide with that factorial in this situation. So here the condition is all the vowels remaining together. So if I take vowels I, 2 times I, these two vowels, then I am taking E. Firstly, I am taking U, this is also, so this become 1, 2, 3, 4, and finally, how many consonants are left? N, V, then R, then S, then T, and then Y. So I just can say that we have 1, 2, 3, 4, 5, 6. These 6 different consonants. And we have how many vowels in the number? We have 4 vowels in the number. But out of these 4, 2 are repeated. And we are bound to take all these vowels together as required in the problem. If this question is free, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then what is the answer of total arrangements? Factorial 10 upon factorial 2 for the 2 identical letters, 2 identical I's. Answer will be this if all are used and 2 I's are of same type. But here 1, 2, 3, 4, 5, 6, these 6 are the different, and all these 4 have to together means we are taking this entire lot as the one letter. So this becomes factorial 7 upon 2 y's are repeating factorial 2 into what and y. These four letters are together, but together they can interchange their positions. So we can say four letters can change their position in how many ways? Factorial 4 ways. So this is the total ways of arranging, and after simplification the answer will be 6060480. So the problems of the permutation can be increased with the level of difficulty, but only after having a read and understanding the condition we can solve the problem of any level with the help of the formula linear permutation, NPR, factorial 0 and some others. Now in the chapter of permutations and combinations, after discussion a lot about the permutations, I would like to tell you what is a combinations. In fact, the arrangement is a separate name of the permutations, whereas the selection is the correct explanation of the combinations. Now the question is, we represent the combination by C if there are n objects and we want to select R out of it, then formula is NCR. NCR means out of n objects we want to select R, and if it is NPR it means that we want to arrange R objects out of n. So to explain you about combinations, always remember where the selection is applicable, meaning by the combination is required. The formula of the NCR is factorial n upon factorial r into factorial n minus r. This is the first result, that is NCR is equals to factorial n upon factorial r into factorial n minus r. We also say that answer of NC n minus r. NC n minus r is the same result factorial n upon, in place of r in the denominator of the first result we will supply n minus r. So this will replaced by n minus r, and in place of this r if we write n minus r, then n minus r will reduce to factorial r. So what is the first result? The selection of r objects out of a group of n objects. Formula NCR is given by factorial n upon factorial r into factorial n minus r. Another result which is quite related to this, NC n minus r is also equal to same factorial n upon factorial r into factorial n minus r. So from these two results, result number 1 and result number 2, what we can conclude? This implies NCR is equals to NC n minus r. Another property of the combination is that if NCX is equals to NCY, it means that, what implies this, that either x is equals to y, or we have to say that x plus y is equals to n. If NCX is equals to NCY, then what has to be? Either x is equals to y, or the sum of these two values x plus y should be equal to n. It is very much clear from this conclusion that r plus n minus r is equals to n. Another property is that value of NCR plus NCR minus 1, after solving this comes equal to n plus 1 CR. So NCR plus NCR minus 1 is equals to n plus 1 CR is one of the property which we will use in solving the problems for our combination. Now another result which is definitely required for solving the problems is NCR is also equals to N by R into N minus 1 CR minus 1. So when we will see that actually selection is required out of some objects, then it means that we are supposed to apply the results of combination. Now I am taking a problem where we will use that how the value of sum of few combinations will be calculated. The problem is evaluate 47C4 plus sigma I is equals to 1 to 5, 52 minus I C3. So first of all I am writing 47C4 plus, if I take I is equals to 1, this will be 52 minus 1, that's mean 51C3. If I take I is equals to 2, as I is moving from 1 to 5, so if I take I is equals to 2, this will be 50C3. If I take I is equals to 3, it will be 52 minus 3, 49C3. And I am using the sign of plus because it is sigma. Now I have taken 1, I have taken 2, I have taken 3. Then if I take 4, on taking 4 it will be 48C3. And the last, the value of I is 5, so it will be 47C3. This is the expansion of this part. Now I will use few properties to give the compact answer of the problem. As we know, what we know, as we know that NCR plus NCR minus 1 is what? N plus 1 CR, as explained you in the introduction of the combination. So 47C4 plus 47C3. The combination of this and this is depending on the result NCR plus NCR minus 1 is equals to N plus 1 CR. So what is this? 47C4 plus 47C3. By using this formula, we can write 48C4 because N is 47 in first and last. In answer right hand side, it is N plus 1. So it becomes 47 plus 1, 48C4. Then plus I am taking this 48C3 because this part and this part is used to convert 48C4. Now I am taking 48C3, then I am taking 49C3, then I am taking 50C3, then I am taking 51C3. It's very clear the same formula can be used in first and second. 48C4 plus 48C3. It gives us 49C4 plus 49C3 plus 50C3 plus 51C3. If I use 49C4 plus 49C3, same result, I will get 50C4 plus 50C3 plus 51C3. Now the same will be applied in 50C4 and 50C3. The result will be 51C4 plus 51C3. Same result applied here. Final answer comes 52C4. So the answer of this part is 52C4 by using the properties of the combinations. Now I am taking an interesting example belonging to the cards, that what is the number of ways of choosing 4 cards from a pack of 52 cards. We know that there are 52 playing cards. In these 52 playing cards, 26 are red. These are the diamond, 13 card, and heart, 13 card. 26 are black. They again are 13 of club and 13 of spade. Now in these 13, One is the ace, second is 2, 3, 4, 5, 6, 7, 8, 9, 10. 11 numbered card is known as jack, 12 is queen and 13 is the king. Jack, queen and king are known as face card, whereas if ace is involved in their group, this become the group of honored cards. So what I want to tell you, there are 52 cards. What is the number of ways of choosing 4 cards from a pack of 52 cards? So first question over here, that if I have 52 cards and I want to choose, I want to select, then answer is 52C4. First answer, that is selecting 4 cards, that is the direct answer is 52C4. If I apply the formula NCR, that is factorial n, that means 52, factorial r, that means 4, and factorial n minus r means what? 48. If we simplify it, we will get, the result will come 270725. So what? After simplification, so this is the total number of ways of selecting the 4 cards from a group of what? 52 cards. Now we are coming with some conditions. In how many ways? In how many ways these 4 cards are of same suit? Suppose there are, you know well, 4 suits. That is, one of the suit is the diamond, another is the heart, next is the spade, and the last is the club. So if all 4 cards are falling in the same suit, that means first part is required, that these 4 cards can be from the 13 cards of the diamond, or means plus these 13 cards can be from the heart, these 13 cards can be from the spade, or these 4 cards out of 13 will be from the club. So as in the problem we are finding, this is the matter of selection, not of arrangement. We may select 4 cards out of 13 of the club, we may select 4 out of 13 of spade, we may select 4 out of 13 heart, and we may select 4 out of 13 diamond. So this can also be written as 4 into 13C4. 4 into 13C4, and after simplification the answer of this part will be 2860. If I go to solve the second part, 4 cards belonging to 4 different suits, it means that what happens, that one card is from the diamond, one is from heart, one is spade, and one of the card is from the last, that is what? Our club. So if I say one of the card 13C1, one is from heart, and so we are using multiplication, one is from here, if I have taken it is from heart, it is from diamond, one is from club, and one is from the last, that is the, we can say this is diamond. So there are 4 suits, first is from first, second from another, third is from different, and fourth is from last. So simplification of this will give that 13C1, that's to the power what? 4. So the answer will be, as we know, 13C1. 13C1, this is factorial 13 divided by factorial 1 into what? Into factorial 12. So the answer will be 13 raised to the power 4. This is the way of answering the second. Third are face cards. We know there are only 12 face cards. So out of these 12, we have to choose 4. 4 cards are from face card. 12C4 factorial 12 upon factorial 4 into factorial 12 minus 4. This answer of 12C4, The answer of 12C4 is 495. So 495 ways will be selection of 4 cards out of if they are from the face cards. Fourth one, that is cards are of same color. That's mean either the cards are red or the cards are what? Black. So 26 are the cards red. 26C4, that is 26, either the cards are the red or the cards are black. 26C4, either 4 cards are from the black color or 4 cards are from the red color, either or. That's why I am using here plus. Answer is 2 into 26C4. 2 into 26C4, the answer of this problem when you will simplify 29900. So this is the way where we will apply the formula for calculation, that is this value comes out 299900, that is 2999900. So this is the way of solving the problems of permutation under some different conditions. Now one more problem of combination, that is how many different words each containing 2 vowels and 3 consonants can be formed with 5 vowels and 17 consonants. We are available with 5 vowels and 17 consonants. We want to make as many words as many we can, but condition is that the word must have 2 vowels and 3 consonants. So obviously first I am telling you ways of selecting 2 vowels out of 5. The answer is 5C2. After selecting 2 vowels, we need to select 3 consonants. Second, number of ways of selecting how many consonants? 3 consonants out of how many? Out of 17. This implies we have how many choices? 17C3. The problem is of AND, that we have to opt 2 vowels and 3 consonant. So total number of ways of selection, total selections are 5C2 multiplied by 17C3, because it is AND. We have selected 2 vowels and 3 consonant. But after selection of these 5 letters, these 5 letters can be arranged in factorial 5 ways. So what implies this? This implies required number of words. Required number of words is 5C2 into 17C3 into factorial 5, because these 5 words again can be arranged in factorial 5 ways. Simplification of this is 816000. This is the total number of ways of arranging, making, framing the 5-letter word out of how many vowels? If 5 vowels are available, 2 are required to take, 17 consonants are given, 3 are needed. Then with this condition, we reach to the conclusion. First we will select what? Vowels. Then we will select consonants. Then we will take their arrangement, and for 5 factorial 5, and we will calculate, the answer will come out to be 816000. Now I am taking one problem where we will use the circular permutation. In fact, if there are 10 persons, they want to be arranged in a queue, there are factorial 10 ways. But if there are 10 persons would like to sit around a circular table, there are factorial 9 ways. Out of an object, their linear arrangements are factorial n, and their circular arrangements are factorial n minus 1. It's always because for the circular table arrangement, we have to keep fix one person to make the different arrangements. So the question is on the theory of selection and arrangement, both, but circular permutation will be used. In how many ways can a dinner for 21 guests be hosted on two round tables which can accommodate 16 and 5 persons respectively? One businessman invites 21 persons and there are two round tables. On this, around it, how many persons can sit? 16, and around this small table 5. So 21 guests. Number of ways is 21C16. First 16 guests will be selected from the 21 guests. Then remaining, how many are left? 5. And guests are how many? 5. So this become 5C5. This is the selection of the first 16 guests for the first table, and then for 5C5 into, because these 16 guests first have been chosen, then they can be arranged on the circular table. So circular permutation, circular arrangement will be 1 less than what available, that is factorial 15 into 5, that is 5 guests around the table, so that will be factorial 4. So this is the total possible arrangements that a person can invite 16 guests, and he is having two round tables on first capacity of 16 and another capacity is what? 5. So the answer will come 21C16 into 5C5, because all 5 are to be selected, into factorial 15 into what? Factorial 4. So this is the total way of arranging the guests.